animals. So it gives me immense pleasure to introduce Dr. G.V. Venkataramana, who is presently heading the Department of Studies in Environmental Science, University of Mysore, Mysore. He obtained his master's, MPhil degree and PhD degree from Bangalore University, Bangalore, that is Manabharati campus, and he also has the experience of working at the USA, one of the leading universities in USA, that is as a postdoctoral fellow at School of Forestry and Environmental Studies, University of Yale, New Haven, Connecticut State, USA. So he visited there in 2016 on one of the Indian prestigious fellowship, that is Raman Postdoc Fellowship. And he is a member of several academic bodies like BOS, BOA, and various other academic bodies in UIM, as well as University of Mysore, as well as several other universities within state, as well as outside the state of Karnataka in different universities. And he received Sir C.V. Raman Award from UGC, and also Young Scientist Award of and Senior Scientist Award from DST SCRB. So he is member of several academic bodies like Indian Association, that is Indian Science Congress Association, then National Environmental Science Association, then Biological Society of India, like several other professional bodies. And he completed so far 7 projects funded by UGC, DST, IOE, MHRD, and Ministry of Environment and Forest and Climate Change. And he is presently handling one project funded by KSTA, that is Karnataka State Science and Technology Association, major research project. And he has successfully guided 5 PhD students, and presently a few more are working under his guidance. And he has published almost more than 80 research articles in leading international journals. And he attended several conferences, seminars, and workshops, as well as he has organized 2 conferences under his chairmanship. And he is member of several the committees within the university, and is very actively engaged in research, particularly in the field of this aquatic biology. And he is very much concerned with the environmental aspect. He is the leading person in the environmental aspects. So, on behalf of all the participants and on behalf of academic staff college, and on my personal behalf, I take this opportunity to welcome Dr. Venkataramana GV, Professor and Chairman, Department of Studies in Environmental Science, Manasa No. 3, University of Mysore, Mysore. You are most welcome, sir, to this afternoon talk.
Thank you, sir.
He is going to present on the title Air Pollution Properties and Control Measures. So over to you, sir.
Thank you, sir. Thanks for giving detailed information about me. Good
Yes,
afternoon, Ondal.
Good afternoon, sir.
Good afternoon.
My voice?
Yes, sir.
Yes, sir.
Clear.
Very good. Okay. So today I will share you some information about our research part, and also what is our air pollution status in India and other countries. It is a burning issue nowadays. And what are the properties of that major air pollutants? And is there any control measures? I think maybe the properties are more. We'll see wherever it is necessary. I will highlight that information, and many slides are there. You all know that air pollution, our natural resources mainly. Natural resources like water, air, and also the soil. So I'm not talking about the soil and also the water, because you all know that the information about the water and the soil. Now the air pollution in India and also other countries facing a lot of impacts and also the problems and also lot of emissions. The air pollution mainly, it is the definition, undesirable changes biologically, chemically, and physically in our ambient air, in our surrounding air. So bringing undesirable change in a desirable places, so that we are call it as a air pollution. In that air pollution in the India nowadays facing a biggest problem. You all know that nitrogen percentage 78%, oxygen 19 to 20%, and also carbon dioxide should be 0.03% actually. So this and remaining all traces of these gases present in our atmosphere. In that air pollution, how this causes this variation of these percentages, nitrogen or oxygen and even carbon dioxide. I think you are aware about last November 30th to December 10th, there was a conference held in Dubai, that is COP, Conference of Parties, that is 28th conference. That is all 158 or 178 countries participated, and also they discussed about how to reduce our gaseous emissions, how to control our air pollution. That was the agenda. That is 28th conference, COP, we will call it as a COP. Okay. After that Stockholm conference 1971, continuously they are conducting this type of conferences every year. How to bring down our emissions with how to control our global warming and current issues and climate changes. Still we are, I think today the temperature of our Mysore or even Karnataka or Bangalore, 33 degrees centigrade. They expected that 34, 35 this month. And next to the 6th, today Deccan has given the detailed information, the predicted temperature and also predicted temperature of this month and also next month. So that means there was a literature history says that in earlier, when the earth originated or earth's origin, our surface temperature, there is a earth temperature that time, during that time, -15. So now the temperature is 33, 32, 34, sometimes 40 degrees centigrade also. We are already experienced. So that COP28 held in Dubai last November 10th to December, November 20th to 30th to December 10th. So discussed about, the president of that conference expressed the views that we have already crossed global warming. Now we are entering global boiling. So that is the situation. The global boiling, next future days we are going to experience this. So we already crossed this global warming. Now we are in global boiling. So that means until unless, if you start your burning of our fossil fuels, until unless, if you stop all this, the emissions with respect to the greenhouse gases, that is carbon dioxide, methane, and ozone, ground level ozone, and also CFCs and other gases. So the country-wise, the top percentage of emission of this carbon dioxide, first China, second is India. So recent report says that every year we are producing 2.8 billion tons of carbon dioxide into the atmosphere, only India status. So regarding that, you all know that the pollution, air pollution. One second, okay. Are you following? Yes?
Yes, sir.
Are you
Yes, sir,
listening
yes,
my voice?
Yes, sir. Yes, yes.
Okay.
Yes, sir. Yes.
In the future days, no doubt, we are paying a water bottle, and in future days we have to pay one more bottle, that is oxygen bottle. If you continue this emissions in the India and also other countries. Okay, so the world, India producing the air pollutants with respect to different categories that I will speak to you later. So India is the world's largest consumer of fuel, agriculture, wood biomass for energy purposes. From the most recent available nation, India 148.7 million tons of coal, replacement worth of fuel wood and also biomass annually for domestic energy use. So Indian national average annual per capita consumption of fuel wood, agriculture waste, biomass was 206 kilogram coal equivalent. The overall contribution of fuel wood, including sawdust, wood waste, was about 46% of the total. The rest being agricultural waste and biomass dung cakes. So traditional fuel, domestic energy used in rural areas, rural India, in accounts about 90% of the total. In urban areas, this traditional fuel constitutes about 24% of the total. So India burns tenfold of more fuel wood, so every year, than the United States. The fuel wood quantity in India is different from fuel wood of the United States. So that means why I am telling this means, so we are depending more the burning of fuel, one, and burning of more agricultural waste, and also some parts burning of this municipal solid waste and natural fire. So these are all contributing India's, which are highest level of air pollutants in Indian states. The world has identified, the world has recorded 33 cities which are most polluted. Among the 33, 22 from India. Imagine the what level of air pollution we are causing, and we are emitting, and we are polluting the air, ambient air, in a larger scale. So in that air pollutants, majorly 6 air pollutants that we will discuss next coming slides. So that 6 air pollutants which are producing number of secondary air pollutants. For example, primary air pollutants which combines with another primary air pollutant to form a number of secondary air pollutant. This secondary air pollutant leads more hazardous or more toxic or more impact on human health, with many reports coming and also many works are doing on that. What is the India's rank of air pollution now? So India is ranked 8th in the global list of countries with the most hazardous air quality, and has votes about 12 of the 15 most polluted cities from Central and South Asia. That is on 14th March report. So data from more than 30,000 air quality monitoring stations across 7,323 locations in 131 countries and also territories, regions was analyzed. That is air quality index, air quality indexes, air quality scientists. So India has ranked 8th in the global list of the countries with the most hazardous air quality, and boasts about 12 of the 15 most polluted cities from Central and South Asia. Then air pollution in recent years has become one of the most critical environmental issue. According to 2021, the World Air Quality Report, almost every Indian city exceeded the recommended World Health Organization. So World Health Organization given the table, or World Health Organization given the reports, that is a permissible limits. So that is the report, almost every Indian city exceeding the recommended World Health Organization limits. So Greenpeace India and Heat Wave Action Coalition, so India are writing to the Chief Minister of Delhi with the serious health concerns of Delhi. Delhi is inching towards the scoring summer. Okay. The summer season is expected to bring higher than normal temperature to most parts of India. Why is this happening? You all know that greenhouse effect and greenhouse gases. So the sun rays falling on the earth's surface, some part of it is reflected and some part absorbed. Where it is absorbed, all our gaseous pollutants which are releasing into the atmosphere, that absorbing that heat, radiation heat. So that directly or indirectly, we are feeling more temperature. That is nothing but greenhouse effect. Okay, so greenhouse gases and also this air pollutants absorbing the radiation energy that is falls on the earth's surface from the solar energy. So that is heat is generating because of this greenhouse gases and also this air pollutants. So that is why we are expecting more higher temperature than normal, and in some cities exceeding above the World Health Organization. That is a greenhouse effect point. So Mumbai clocked the highest maximum temperature in the country, 39 degrees centigrade, 6 degrees above the normal of this time, the last year. That is 23 March. The most India saw the warmer than the usual Sundays. So with Delhi recording its hottest day for the year of the 34 degrees centigrade Celsius the last year. So that is Mumbai cracking the highest maximum temperature in the country, that is 39.4 degrees centigrade above, that is more than 6 degrees in the last year, the March report it is. Okay. Then India's air quality is 7 times worse than World Health Organization guidelines. So World Air Quality Report in 2020 reported. So roughly about 60% of the cities in India included in the report recorded the annual, the PM, that is we are talking about the PM level, 2.5 PM. That is PM broadly classified against 6 groups. So that we will see the later. So PM level, so at least 7 times higher than the World Health guidelines. So the average PM 2.5 level in 2022 was 63.3 microgram per cubic meter, only slightly lower than 68. And Bihawadi in Rajasthan was found to be the most polluted city in India, with alarming about the 92.7 the microgram per cubic meter. And Delhi emerged the most polluted world metropolitan city, the PM level 92.6. So that is the PM status, particulate matter. So the particulate matter is a major air pollutant. Particulate matter is a mixture of many solid and semi-solid particulate matters, solid or semi-solid chemical compositions. So that is the status of PM 2.5 in Delhi and also the Rajasthan, and even Bangalore reported 170, etc. Okay, these are the most polluted cities in India given the latest data. So what is the air quality? How to define the air quality? What is the air quality? Okay, so that is what is the clean and what we can mean the quality. So mean the reasons for air pollution control programs is to protect the public health, define air quality based on its effects on people and environment. So effects of air pollution are, it may be chronic and not immediately obvious. There are many methods that I'm not talking about this measurement of this air quality types and also the measurement of air quality generally, that is. So that is, I'm going to skip where there is a property is the main important, my point today. Primary air pollutant, secondary air pollutant. So these are the sampling methods which we are doing. And also we are concentrating only on particulate matter concentration, particulate matter types, particulate matter characterization, particulate matter impact. That is a major air pollutant. So these are, I am skipping this because these are the methods of sampling, meteorological changes, that is. Okay, there is a calibration procedures. After each instrument, there is a sensors. There is a conventional method of measurement and also non-conventional method of measurement. The conventional methods are the one which you can That is that equipment you can collect the samples and also you can monitor how much it is there. But non-conventional, you can see the air quality, but you cannot collect the samples. So that is a major difference of conventional air sampling method and non-conventional air method. I'm repeating this. Conventional is the one that instruments, you can see the air pollutant quality and also you can collect the samples, whether PM or gaseous pollutants, by using a substance or a particular adsorbent and also absorbent. So that is called a conventional method of sampling. And non-conventional is the one which it's a sensor based. They can see, they can record the air quality, PM level or NOx or SOx, whatever it may be. But they cannot collect the samples in non-conventional method of sampling. There are many methods of using that sampling that I am going to skip this part. Yeah, this is the one which we are doing the research in the Department of Environmental Science. Okay, so this is the instrument developed by Envirotech. This type equipment is there in even pollution control boards, all pollution control boards, and also state pollution control boards. They are continuously monitoring this. So the mainly this is total suspended particulate matter and PM10. So this we have this instrument, so we can collect this, placing many places and placing this device, this instrument in different zones. So what we did in the laboratory, so we'll place this equipment in polluted zone and moderately polluted zone, highly polluted zone, and also less polluted area. We'll keep this device or this equipment nearly about 15 days. We'll run continuously by using this device, and this flow rate, everything is monitored, and particle 10 microns collected in the filter. So that may be the sampling time, you can fix it, and sampling time recording is automatic and also manually program, we can operate it. So this is the where we can collect the PM here, particulate matter 10, and we can collect the total suspended particulate matter here. So this is the device which we are having. It is sponsored by Department of Science and Technology in 2018 and 19. And this we are using, and we are collecting this particulate matter only, PM10 and TS, total suspended particulate matter. So this is how it works it is. So like this you can see this. See the filter paper, if you collect Teflon filters, so how does it looks like? TSPM, total suspended particulate matter. After placing this in any highly polluted, that is a place, highly polluted area, the suburb bus stand we have fixed, and moderately polluted after in the ring road areas we have, and slightly polluted after ring road nearly about 10 kilometer distance, and non-polluted areas, that is we have selected some residential zones or the little forest area which we have selected. So this continuously we are monitoring, continuously we are collecting, and we are doing this characterization also, and we are conducting many experiments on animal models, collecting this total suspended particulate matter and 2.5 also. So this, it looks like a black carbon. If you keep this one in suburban area, one day is enough to collect a maximum the particulate matter, so total suspended particulate matter in that area. So like this, the filter paper it is. So where this PM10, when we place this filter paper, that is partially, and also the filter paper converted like this. Then we will extract using the methanol and sonication we will do, and after that characterization we will do in the laboratories. This is about 2.5 dust samplers that which we are using is 2.5 collection and PM10 collections we are doing. So just to show this, what research we are. So today I am going to give the information about what is the research which we are doing in air pollution aspects after knowing the types of air pollutants and impacts of air pollutants and categorization of air pollutants and properties of air pollutants. Okay, so after that we will taking one particular type of air pollutant, so that we are conducting the exposure methods in animal model. Okay, that is the model which we are using. I'll skip this also. Yeah, there are many gaseous sampler methods also. You know that after PM, there is a sulfur dioxide, it is air pollutant, primary air pollutant. NOx is a primary air pollutant. Lead is a primary air pollutant. Okay, sulfur dioxide, SOx, NOx, and carbon monoxide, carbon particulate matters, and types of particulate matter, and this we are using this considered as a gaseous sampler, sulfur dioxide. So this is the sensor based sensor measurement of sulfur dioxide by UV spectrofluorescence method. So this is just a sensor based. We cannot collect it, but we can measure this how much of sulfur dioxide in ambient air quality. Okay, in ambient air. So this using the sulfur dioxide plus UV will get this in the sensor. And oxides of nitrogen we are following chemiluminescence method. And this is the measurement of NOx by chemiluminescence. It is sensor based. It cannot be collect the samples, but you can sense that how much this NOx present in. I think you might have seen this in all railway stations. The pictures the real time monitors. The same principle which they are using and which working to show the how much of NOx present in 100 meters circumferences. Sensor based one gaseous NOx. Well, carbon monoxide NDR method will monitor. So these are all sensor based method of knowing the gaseous air pollutants present in ambient air. Yeah, this is the one we have now. We are using this gaseous samplers. Gaseous samplers using a particular type of adsorbent. So each, for example, ammonia or NOx or SOx or even the sulfur dioxide. So each one, there is a separate adsorbent which we are using here. Each there is a impingers, these are the impingers. So in this we will fill the specific adsorbent into that, and we will expose this gaseous sampler into the same how we are going to do this particulate matter. So that is highly polluted, moderately, and also these less polluted areas. Then after that, we will collect that sample, we will analyze it in the laboratory. So how much of this gaseous sampler, gaseous pollutant present in a particular area. So this we are doing this provided by Envirotech. This we are analyzing in our laboratory. This is a schematic diagram of how we are going to set up the impingers with different gaseous air pollutants in our laboratory, which we are doing this. So this is a impinger. Each one, the adsorbent is required, and also there's a flow diameter and also flow speed, which we are presenting. I think this is the method of measuring and analyzing the air pollutants. This is the gravimetric method, PM10 2.5. The particles trapped and collected in the filters, and filters are weighed and determined by volume and extracted using methanol and evaporated using nitrogen, and also characterization using different the HRD methods. Then there is a lead, mercury, also zinc. You can do this, and SOx, ozone, spectrophotometric method, chemiluminescence method, and also this gaseous sampler, volatile, the gas chromatography. These are the specified methods given by pollution control boards and also developed by some other agencies. So through which you can measure our gaseous pollutants. I think standards, you all know that. National Ambient Air Quality Standards developed by NERI, National Environmental Engineering Research, and also Central Pollution Control Boards. So that may be ambient air quality status desired as low, moderate, high, and critical. Okay. Two types of national ambient, primary and also secondary air pollutants. Primary ambient air quality, secondary ambient air quality. Primary air quality are sulfur dioxide, NOx, even PM. And second air pollutants, ozone, acetylene, that is H2SO4. So the secondary air pollutants, national ambient air quality, and primary national ambient air quality. These are the standards how much it should be. So sulfur dioxide annual average 24 hours. So that is 120 microgram. Okay, that is in industrial area, residential area, a sensitive area. That is fixed in the Pollution Control Board's National Ambient Air Quality Standard. This much should be there. But we are exceeding this all if you collect 24 hours or annual average or 8 hours average. So that may be residential area, industrial areas, and also sensitive areas. This is prescribed in National Ambient Air Quality Standards given by that is NERI and also Central Pollution Control Board, even the World Health Organization. Okay. Then ambient air quality 24 hours. Okay. So this is our air quality index. Is a number used by government agencies to characterize the quality of air at a given location. See, if the value, air quality index value, when air quality index value is this range 0 to 50, the air quality health concerns, it is good. And also the color is green, air quality index. If 51 to 100, it is a moderate yellow color. That may be a feature. It continuously increases, it may enter into the orange. 101 to 150, unhealthy for sensitive groups. What is that sensitive groups? The age group children's up to 14 age. And also the people who are susceptible to the other diseases. So that is the sensitive groups. That is an orange color. And if exceeds 151 to 200, unhealthy, that is indicating as red. 201 to 300, very unhealthy, that is a purple. And 301 to 500, hazardous and maroon color. So that majority of our Indian cities, majority of your 22 cities which are identified, so that is always showing orange, red and purple color. Okay, and sometimes in yellow. So green, where the forest areas, where the clean cities, that you may expect green in some location, but in all the places which the air quality index says, or Pollution Control Board is indicating that exceeding 50, 100, sometimes 151 to 200, sometimes 200 to 300 also in some places like Delhi and all metropolitan cities. So this is our components present in the air. I told this in the beginning. Nitrogen 78.8%, oxygen 20.94%, argon remaining totally. So remaining all are negligible percentages, 0.00, 0.001%. The carbon dioxide 0.03% should be. But many places, the carbon dioxide is the one which is the major greenhouse gas, which emitting in a large scale, which including which in the ambient air, which we are emitting. All these anthropogenic activities, all man-made activities, all industries, all the engines, missions, we dumping this carbon dioxide into the atmosphere in a large scale, which decreasing the percentage of this 20 and also which decreasing the percentage of required percentage of 78 in the atmosphere, which we are facing the greenhouse gases, greenhouse impact. The composition of air, it may change in season, change in altitude, change in solar activity. Okay, and oxygen, oxygen highly reactive, exerts marked influence the various geochemical cycles. Most of the atmospheric oxygen, photosynthesis and ultraviolet radioactivity, the expired air concentration reduced 16.4%. We are expecting 20% in the atmosphere. So 16.4%, that is concentration reduced to 16.4%. Okay. The concentration of carbon dioxide increased 4.24%. This is because this is the one interrupting the quality of oxygen and also the percentage of nitrogen. Okay. See 4.2% the concentration of carbon dioxide. We are 19 to 20% expecting this oxygen present in the atmosphere, but it is reduced to 16.4%. This and all the layers, I'm going to skip this troposphere, stratosphere, mesosphere, thermosphere, exosphere, so that distribution of this air pollutants or air or gases into the layers of the atmosphere, that I will skip this. Even the explanation about the troposphere, stratosphere, mesosphere, and thermosphere. I think these are the layers which separating the oxygen and also the temperature, humidity, and our air quality, and our nitrogen percentages. Yeah, meteorological factors, which may major parameters, temperature, wind, humidity, atmospheric weather, that and all. I think that you know this. Some historical perspectives of this air pollution. You see, the Belgium, December 1930, the area was covered blanket, a thick fog for about 5 days. More than 60% died as a result of toxicity due to oxides of sulfur. Where these oxides of sulfur producing all from industries emissions. A large section of population become ill in the year 1930. Just I want to show some history of what are the incidents happened, including India. Okay, in Pennsylvania, 1948, intense foggy condition observed. So that is a place. Okay, large population more than 40% became ill due to that exposure. 2, manifested ocular and throat irritations and caused due to the excessive sulfur compounds. These are all sulfuric acid, which from industries, the major source producing or emitting this sulfur dioxide. This happens. See, 1952 and 62, London smog. Everyone knows this. Okay, so London smog, the death of thousands of people because of this industrial emission sulfur compounds and also the using this diesel emitted diesel emission engines. In New York also reported 1953, 62 and also 66. The smog caused substantial morbidity and also mortality. You all know that 1984 Bhopal gas tragedy, leakage of gases methyl isocyanate from pesticide plant. More than 5,000 people died. Still, many people are suffering. Many more thousands are affected. Variety of illness, including respiratory dysfunction. So these are all which we are making the major disasters into our environment aspect. You know this 1986 Chernobyl disaster. And Los Angeles, California, the problem that was associated with various respiratory symptoms and caused many respiratory irritations and damage on vegetation also. So that is history perspectives. And coal dust explosion in China 1942, forest fires 1999-98 impact on health productivity, and nitrogen oxides and hydrocarbons present in the atmosphere. The toxic compounds were produced through the photochemical reactions. So photochemical smog pollution. I think many places accumulation of the smoke to form a smog. This is the combination of the SOx, NOx, and also sulfur dioxide. So this is many places cancel the flights, canceling due to that scarcity of because of that you cannot see the objects. I think classification may be source of emission and physicochemical characteristics, effects, that and all I am skipping. If the sources, no need to explain it. Natural sources and man-made inductive activities. There is a natural source also. For example, volcanic eruptions, okay, forest fires, or microbial agents. And also there are some plants which can produce volatile organic compound also. These are you cannot prevent it. We cannot prevent it. There are natural sources of this air pollutants. Volcanic eruption, you cannot stop it. Discharge from marshes and also forest fire sometimes. And even the plants, there are some trees which can release most of the volatile organic compounds. There are some trees. So that is a natural source. And natural source is not that much of magnitude into the atmosphere in the air pollutant. So mainly it's coming from man-induced activities. There is incineration and oil refineries, dust particles, or dumping of this waste material, burning of municipal solid waste, burning of agricultural waste, and automobile emissions, engine emissions, industrial emissions. These are all man-made emissions which we are contributing in large scale in the atmosphere. Two major types gaseous pollutants are particulate pollutants, broadly classified. Yeah, that is about the history of air pollutant, definition of classification of air pollutants, and the status of air pollutants in national and also international. Okay. Now we'll see the properties of these air pollutants. What may be the individual, the property, how it looks like, what is the property, how it reacts, how it forms into the atmosphere. Okay. So that is air pollutants, basic properties of the major air pollutants. The quality in a substance or a material or mass defined or characterized by. One of the property of copper is that it conducts heat and electricity well. That is, and we value herbs for the taste, but we forget that also have a medicinal properties. So that means each one has its own property to express the characteristic features. Okay. So these are the 6 major common pollutants categorized. These are major air pollutants. Carbon monoxide, ground level ozone, sulfur dioxide, particulate matter, nitrogen dioxide, and also the lead. The CPCB or World Health Organization have broadly classified 6 common pollutants in air. Okay, so that is, you see the nitrogen dioxide. This is a primary air pollutant. Nitrogen dioxide is a primary air pollutant. It combines with carbon monoxide or it combines with sulfur dioxide to form a secondary, or oxygen to form a secondary air pollutant. So primary pollutant, nitrogen dioxide, is one of the group of gases called as the nitrogen oxides, which is formed during combustion of fossil fuels. When you burn this, it will form this. Okay. So the chemical formula NO2, the main source, how this enters into the atmosphere means it is a vehicular exhaust, which is a primary source, vehicular exhaust. Color may be reddish or brown gas, odor, pungent and irritating smell. So nitrogen dioxide, it is a primary air pollutant emitted from vehicular exhaust. Where is the major source of this? Vehicular emissions. See the number of vehicles, and also the emissions, and see the urban status, and see the percentage of this NOx present in there. The molecular mass of this 46, density 1.8, melting point 9.4, boiling point 21, 1.5 degrees centigrade. Solubility, soluble in nitric acid and also chloroform. The structure of this NO2, bond length. Okay. The bond length between the nitrogen atom and oxygen atom is 119.7. Okay. So that is the bond length between oxygen to oxygen 134.3 degrees. This is the property, it can melt minus 9.3 degrees centigrade, boiling point soluble in all nitric acids and also chloroform. How this nitrogen dioxide is formed, that is most important. That is our environmental aspect. Okay. In natural source, nitrogen oxides occurs. These are nitrogen oxides occurs from lighting stroke. And very high temperature in the vicinity of lighting, what causes the gases oxygen and nitrogen in the air to react to form a nitric oxide. NO. React to form a nitrogen plus oxygen to react in high temperature to form a nitric oxide. It's not a stable compound. It readily reacts with more oxygen to form a nitrogen dioxide. It is unstable NO. Okay, that way, continuously like a chain reaction, nitrogen, oxygen, it is unstable, then again nitrogen plus oxygen to form a nitrogen dioxide. In the atmosphere, it continuously, it forms like this. Okay. That is a, how it reactions, what are the source of forming this NO2 it is? Nitrogen NO2 reacts with air, with water vapor to form a nitrous oxide. That is secondary repellent. And nitric oxide, then toxic agent nitrates. This contributes to production of acid rain that kills trees, fish, and also animal life. So where this nitrogen dioxide forms by this process. So this way, the nitric oxide, peroxide nitrates, particles, and volatile organic compound continuously oxygen combines with nitrogen, NO to form a NO2 and O3. So this is the status of how this reaction is taking place when continuously industry is running, continuously vehicle are running, continuously vehicular emissions to release us this percentage of the carbon dioxide and also volatile organic compound, then form a nitrogen dioxide. NO2 emissions, trillion grams to troposphere. The mainly fossil fuel, I told you 21%. Okay. Aircraft 0.5%. Biofuel 2.2%. Biomass burning 5.2%. So this is the areas which contributing to form a nitrogen dioxide. To form a nitrogen dioxide in the atmosphere. See, day and night, how this nitrogen dioxide forms in different ways. During daytime or during night time. Okay. So this half of the part is during night and during, so both the time continuously emitting this much of secondary and primary air pollutants. See, during cool temperatures, so NO in the presence of volatile organic compounds to form a O3, reaction oxygen species to form a NO2 during night time, and O3, NO3, and nitrate radicals and dinitrogen pentoxides, organic nitrates, they're all combined to form a one source of NO2, NO3, N2O5, HNO3. So NO3, N2O2, HNO3 is a secondary air pollutant. How during night time, when the cold temperature, how this VOCs combines with NO, how this nitrate radicals combines with N2O2, how this nitrogen pentoxide combines with N2O5 to form a HNO3. So that is the sun time during daytime and during night time the formation of this day and night, the chemistry of nitrogen. Okay. So during daytime, again this NO plus oxygen to form a O3. Then pan-peroxynitrates to combine with NO2 in the presence of UV radiation to form a NO3, and also during hydroxyl oxides O3 to form a N2O3, and also the important issues nitrogen oxide budget oxidation of volatile organic. So this is the continuous chain reactions to produce NO2 in all the time, even the day and also night, these reactions taking place, this formation continuously in the atmosphere when the vehicle emissions, industrial running, and this formation takes place. The majority of nitrogen oxides emitted from vehicular emissions that I told. However, the gas can react with other gases to form a exhaust and also atmosphere and form nitrogen dioxide. Nitrogen dioxide is harmful to health and is also an important component to form a ground level ozone. You all know that ground level ozone is an air pollutant. Ground level ozone is a secondary air pollutant and also a greenhouse gas. How this ground level ozone forms? Because of this NO2 continuous emissions. How this ozone is formed? Because of the oxides of nitrogens. Okay. So whenever anything is burnt in the nitrogen oxides are formed, this is because the air we breathe is most made up of the nitrogen 78% and oxygen 21%. And these combines when the energy forming a burning material which is available in the that is about oxides of nitrogen, which we are sources from vehicles and also sources from industries and sources from other anthropogenic activities. In carbon monoxide is a colorless gas, odorless poisonous gas produced incomplete or inefficient combustion of fossil fuels, cold or badly turned into engines. Okay. So badly ventilated domestic fuel applications. If you burn the coal in a improper ventilation places, can cause high levels of indoor and can as smoking. As a traffic is a major source of carbon monoxide. Ambient concentrations will generally be highest closely to busy roads. The carbon monoxide is it comes from motor vehicles. Again, reduces transport oxygen through the bloodstream and affects the mental functions, usually acidity, even at low levels. These are the physical properties of this carbon monoxide, I think. Molecular weight 28, formula CO, and this very flammable, burning in the air with bright blue flames, and melting point minus 205 degrees centigrade, boiling point minus 191.5 degree, density 1.250, density of the soluble in many organic solvents, such as ethyl acetate, methyl chloride, acetic acid, about 7 times more soluble in methanol and also ethanol in the water. So flammable limits of in air minus 12 to 75 by volume. So this is, you cannot see these gases, but you can experience it or you can inhale it, and it may lead to many other metabolic changes in the body. How can this carbon monoxide formed in the atmosphere? Again, when combustion of carbon is incomplete, that there is a limited supply of air. Only half as much of oxygen adds to carbon and carbon monoxide is formed. Carbon monoxide is also formed in a pollutant when hydrocarbon fuels, that is natural gas, so petrol or diesel are burned. That is a major source of forming this carbon monoxide in the atmosphere. This is also major air pollutant. So that is the oxidation process. Oxidation of carbon monoxide, production in ozone, production of ozone. Carbon monoxide, hydroxyl, carbon dioxide, and hydroxyl ions. So these chain reactions continuously form carbon monoxide, oxygen, then carbon dioxide and ozone. Okay. So this is the reaction how the carbon monoxide produced from carbon dioxide and also from oxygen to form a RO and to form a O3 from CO. So the oxidation of carbon monoxide, production of ozone is a major source for the production of ozone. The major source of production of ground level ozone is carbon monoxide. It combines with oxygen in the presence of UV light to form a O3. So these reactions Then carbon dioxide. Many places you cannot call it as a carbon dioxide is a air pollutant. When it exceeds WHO levels, you can consider it as a greenhouse gas and also the pollutant. As opposed, carbon monoxide, carbon dioxide is produced completely as fossil fuel combustions. Well, ambient levels do not have any direct effect on health, so it may be important greenhouse gas indeed. That is why carbon dioxide, it is a greenhouse gas. When it exceeds the normal level, it is also a pollutant considered, a contribute to the global warming. It's a major anthropogenic man-made sources. That is road transport, power stations, industries, many places, all refrigerators. So other industrial combustion process and domestic heating, this carbon dioxide emitting. Everyone, if you until unless the fossil burning, that is a source of carbon dioxide in the atmosphere. You know physical properties, carbon dioxide is a colorless, odorless gas. It is soluble in water, ethanol, acetone, and following the properties it is. Melting point minus 15.6 degree, boiling points minus 78.5 degree, and also density 1.977. Properties of the chemical properties of carbon dioxide is a linear covalent molecule. A carbon dioxide is acidic oxide and reacts with water to give a carbonic acid. Carbon dioxide reacts with alkalis to give a carbonate and also bicarbonate. Carbon dioxide with sodium hydroxide to form a sodium bicarbonate. Sodium bicarbonate again sodium hydroxide to form a sodium carbonates water. So this reactions it forms this carbon dioxide. That's why carbon dioxide emission first in China, second in India. That much of billion tons of carbon dioxide contributing to the atmosphere, releasing into the atmosphere. So that is why the biggest percentage in carbon dioxide in the world. First one is greenhouse gas. First percentage that is about 70% carbon dioxide in the atmosphere emissions. This is the major one. All summits, World Health Summit, COP1, COP2, COP28, Rio summits, yes, Rio summit, Rio declarations, yes, and also the agendas, World Health Organization agendas, they are always fighting and also interacting how to stop this emission of carbon dioxide, fossil fuels, alternative solutions. Okay, then come to the sulfur dioxide problem. Sulfur dioxide is produced when a material or fuel containing a sulfur. The major part of sulfur dioxide producing in the atmosphere is due to this natural source, volcanic eruptions. And remaining the industrial emissions, chemical fertilizers mainly. All chemical fertilizers and also some chemical fertilizer industries producing large scale of this sulfur dioxide. It's a colorless gas. It can be oxidized to sulfur dioxide, which is presence of water. Water vapors is readily transferred to sulfuric acid. So globally, much of sulfur dioxide into the atmosphere comes from natural source and major contributors from power stations, and that is 65% of emissions. This is the structure of this property. This compound is a bent molecule and has a bond order 1.5. And the resonance structure can be described using the valency bond theory using S and P. The properties of sulfur dioxide is the biggest, again it is a chain reaction. It is what the acetate is forming, which we are experiencing. And acid water pH temperature is variation. So it is a colorless, though it is a colorless gas and rotten egg odor, it is highly soluble in water. It liquefies easily. Sulfur dioxide dissolves in water to form a sulfurous acid, due to which possess the acidic characteristics. Water plus sulfur dioxide H2SO3, sulfuric acid. It does not support the combustion, nor it combustible. Sulfur dioxide is a strong oxidizing agent. Okay, sulfur dioxide is a strong oxidizing agent. Hydrogen sulfide, sulfur dioxide to form a sulfur and also the water. It also acts as a reducing agent also. So that is why industries or volcanic eruptions, sulfur dioxide emitting in the atmosphere. Okay. And this combines with water vapor to form a sulfuric acid. And again combines with water to form a H2SO4, that what we calling acid rain. How this acid rain? The major part sulfur dioxide in the atmosphere. You can see the sulfur dioxide impacts many monuments. Example of Taj Mahal, example of all brass made statues, which are all eroded, and also the marble, deterioration of marble. So this is because of the sulfur dioxide emission, and also number of lichens are disappear, number of species. So lichens are the good indicators, so which can disappear because of the sulfur dioxide emission in all industrial areas and also the many places. The sulfur dioxide, for example, reaction between dilute sulfuric acid and sodium sulfate to form a sodium sulfate, and iron plus oxygen to form a ferrous oxide and sulfur dioxide. So these are the important the properties of sulfur dioxide. Yes, volatile organic compounds. Nowadays, this is the biggest problem which we are contributing all these gaseous pollutants, mainly the volatile organic compounds, into the atmosphere. The term hydrocarbons is often used when discussing the traffic pollution. This is refers to a chemical of which the volatile organic compounds are subgroup. Volatile organic compounds comprise in a range of chemical compounds, all of which contribute to varying the degree to formation of ground level ozone. Volatile organic compounds also the major part to form a ground level ozone. Okay. The current attenuation focused on 1,3-butadiene, primarily because of one of its source from vehicle exhaust and benzene. The benzene in the atmosphere either comes from combustion or it comes from evaporation of petrol. So levels therefore highest close to the busy roads, the vicinity of petrol filling stations. So only the small concentration of volatile organic compounds are typically found in the atmosphere. Monitoring process is very complicated and also expensive and separating, and which is a major part to form a ground level ozone. Then the ozone. Ozone is an unstable gas. Ozone, ground level ozone is a secondary air pollutant. Annually occurring ozone in the upper atmosphere, but ozone layer protects our earth in the atmosphere. But in the ground level, it is harmful to the health. The ozone is not emitted directly from man-made sources in a significant quantities, but is formed with a complex set of reactions involving, that is, major source from oxides of nitrogen and also hydrocarbons and this volatile organic compounds. So that is why in all the places now we are facing the difficulty of the ground level ozone pollution in the atmosphere. There is the biggest secondary air pollutant which contribute to the greenhouse gas major part. After methane, after carbon dioxide, this may comes under the major part of these greenhouse gases. These are all ozone precursors. Ozone formation, ozone chemistry. I think this and all may be difficult for you to understand and also remember. I will skip this. Once ozone can remain in the atmosphere for many days and is often transported over the long distance. Okay. It is for this reason that is a real reduction on ozone levels can only be achieved through the global action. Lead, I told you this is main. Lead is the atmosphere in history has been combustion of petrol vehicles. Nowadays, lead-free petrol is introducing, and airborne lead levels have fallen dramatically, and lead is no longer is a major problem because earlier there was a lead in the petrol. So now even diesel and petrol, the lead-free petrol is already came in the rule. I think. Are you following, or shall I stop here? Particulate matter, just 2 minutes, I'll finish this. Then again, I want to tell a little about the research work. Okay. So PM is a complex mixture, a major air pollutant in born particles with different size. The composition of all that is less than PM10 micron in size. Dust to smoke, everything. See, particulate matter, suspended particulate matter, respirable particulate matter, fine, soot, all comes under this particulate PM. So facts about the PM pollution, particulate matter pollution. Okay, don't think other way. Particulate matter pollution it is, PM. PM is one of the 6 EPA criteria pollutant, Environmental Protection Agency criteria pollutant. PM has no fixed composition. Particulates may consist either only one chemical, sulfate, sulfuric acid, lead, or number of pollutants, organic chemicals, metals, dust. As UPA described, PM pollution is a mixture of mixtures. Particulate matter is a mixture of mixtures. PM is among the most harmful of all air pollutants. The types of PM particulates, primary, secondary, PM size, PM10, PM2.5, and also PM1. This is the size of the particulate matter. I'll skip this also. The particulate matter in this one. Yeah. See, particulate matter composition is a composition of mixture of many primary and secondary air pollutants. Sea dust, salt, organic carbon, elemental carbon, primary, and secondary precursors, sulfur dioxide or oxide. So all combinations you can say is a mixture of mixture. Hence the EPA categorized a PM is a mixture of a mixture. Okay, this is the particulate gaseous, ammonium, sulfur, nitrate, and also NaCl, organic, elemental, liquid. You can combine all gaseous and also the solid particles and also particulate matters, everything into the PM. That is why when they calculating the air quality index, this parameter is compulsory. PM compulsory for all calculations. If you want to say oxides of nitrogen air quality, they can take this particulate matter value. If you want to say the sulfur dioxide in the atmosphere, they have to count the particulate matter in that. And if you want to say ground level ozone air quality index, they have to consider this. This is a compulsory parameter and compulsory value for calculating air quality index and also national ambient air quality index. So that is why the PM is a most important parameter, most important chemical which can consider all for calculating air quality index. So that is why the PM which we are concentrating in our laboratory, first thing is we used to collect the PM in different sources. We will do the characterizations, and after characterizations, we will convert it to the standards of that, so that known concentrations will expose to the animal model, and in that animal model, we will see the lung inflammations. For that lung inflammation, which we are doing by, is there any alternative to control that PM by natural method and also by chemical method? So chemically, after exposing this PM into the mice, we will see the lung inflammation level, and after that, we will give the antioxidants. either this PM can control or recovery from animal or can reduce this impact in lung inflammation. That we are already doing many the plants extracts. Many plant extracts we are exposing after exposing PM to the animal and after knowing the lung inflammation. Okay. And also the chemical method, NAC also we are administered to see the how this potentiality of this PM. And addition to that, this PM, is there any natural plant has the potentiality to reduce the PM potential if you administer? And also we have developed a chemical which can control the impact of this particulate matter after administration to the animal, that inflammations. Okay. So that is our research part that I will show you this and all many slides I'm skipping. Yeah, this is our research one area, one part of that I am telling. Investigating the toxic effects of particulate matter air pollutants in various emission sources and lung injury and insulin resistance mitigations by antioxidant therapy. So this is one objectives, and this we are doing to collect the PM from different sources and to characterize this PM and using antioxidants, even chemical and natural from plant products. Is there any potential decrease of that inflammations after administration of a chemical compound or after administration of a antioxidant compound? So that is our research which we are doing. So this is the different source of PM: cow dung, mosquito oil, even charcoal in mosquito coils. So this PM we are collecting. So after that, we are producing, you will see the ROS level in that. So, and we will see the DDT assay. We will see the DDT assay and how it is. So, DDT alone, DDT plus PM, DDT plus PM concentrations in agarbatti, charcoal, and also mosquito and cow dung. And after that, we will see the ascorbic acid assay also. And we will see, we will assess this schematic representation of immunoassay after exposing PM and also antioxidants and also the chemical NAC compound. Then what may be the impact and how it is controlled in animal model after giving these antioxidants. Okay. And even objective 2 is this we are conducting, and we are analyzing this comparison and using this assays. Yeah, DDT assay, you see, incendic and also mosquito coil and cow dung and charcoal, and how this immunoassay we are characterizing and using this chemical method and also this antioxidants, we will see the biodiversity and also assess, MTT assess, and we have already significant results we have succeeded. So when the PM, if you expose NAC, it may control inflammation. In the PM exposed animals, if you administer antioxidant compound, we will reduce the inflammation. That is our conclusion in our research part of it. So now, okay, there are many control measures. You will see. Time is up. Okay, thank you. So that is our research part, which we are doing the exposure and using the antioxidants and also by chemical and also the natural method, how to control that inflammation of this particulate matter in an animal models. Thank you, Anandal.
So, dear participants, if you have any questions, you can ask to Dr. Venkataramana.